Hello, I'm Alex Saroyan, CEO of xCloud Networks. I've been network engineer before and still I'm kind of. So about 1.5 years ago, I came to a question because I asked myself, I'm network engineer, me and my team are building and maintaining telecom and data center networks for about 15 years. What we do besides configuring and managing network? We are always busy, but why we are that much busy? And I figured out that most of the time we are doing this. Please open access from between this IP address and that IP address on that port. Increase traffic policer for this customer or configure BGP, and so we are basically doing what people are requesting. And of course, we heard a lot of like, my request is urgent, I'm going to escalate, this is important, this is blocking the project, and so on. So people are pretty urgent, and they have a lot of requests. So we are not only building and maintaining networks, but most of time is going for doing what other people want us to do. And it is not like they always request right things, I believe. So this was the problem, and I wanted to solve. So I decided to create a system where customers, consumers, salespeople, system engineers, network engineers, all people that need something related to the network will be able to define their requirements into intuitive web portal using a couple of mouse clicks, and the things will be done automatically without wasting precious time of network engineers. So about two or 3 months of trying, testing, failing with a couple of my friends, we've got a precise understanding what the concept will be and what we are going to do with. So we decided to take a white box switch. Most of you know what is it. It's kind of equipment available from many vendors, which is kind of open. So it's like Cisco switch, but without Cisco iOS. It's still using industry standard silicon. We need Cumulus Linux because it's operating system, production ready operating system for white box switches, and we need piece of coding. So everything look achievable. So idea was to build a fabric using bare metal switches running Cumulus Linux, then set up a BGP adjacencies between the switches, develop intuitive web portal, and what was important to develop a piece of software which will be run right inside the switches themselves. So we didn't want to develop something which is going to SSH into switch or kind of connect to the switch and do something there. We decided to do something which will be run deep inside the switch. So we built this in our lab. So we set up a BGP. We started using BGP unnumbered. BGP unnumbered is using extended next hop encoding, which is defined by RFC 5549. Unfortunately, it is not available by most of the vendors yet, but thanks to Cumulus efforts of QAGA project, which is currently called free range routing, the BGP unnumbered is available on Cumulus Linux. So with BGP unnumbered, it is very easy and it's very quick to configure the switches. You don't need to set up a link IP address. You just say, I want to run BGP on this port and use this AS number, and it's up and running. It's pretty easy, just 2 commands. Then we set up IP addresses on loopback interfaces of those switches and started advertising those loopback IP addresses. So every switch gets reachability to every other switch loopback IP address. We connect a small virtual machine to this network. We set up our software there, which started to act as a controller. we develop the UI inside the controller, and actually the piece of software which is running in every switch on top of the Cumulus Linux was contacting with the controller, pulling a kind of configuration like I'm this, and switch, do you have any information for me? And pulling configuration and deploying locally. The configuration was started to deploy in distributed manner. Because we were initially focused on the case of carrier network, so we decided to use VXLAN as an overlay protocol. VXLAN is supported deep inside the hardware, so on ASIC level, and VXLAN allows to have up to 16 million of circuits. So the customer traffic, which is entering any switch, for example here, Ethernet frame is encapsulated into VXLAN packet, which is IP packet, and later on it is transmitted over the network from one IP address to another IP address. And we know that layer 3 can scale to the size of the internet, so we were sure on the scaling. There are some virtual machines called service node, and they are used for VXLAN signaling. And we also run polysers on every switch on the ingress. This is supported by most of the white box switch silicon. We had a case when we had to calculate the price. So in carrier network, the price is like how much will be cost for the circuit between this point and that point. And we decided that BGP will be our friend in this case. So we configure, as I told, we use BGP for, so these switches are speaking BGP between each other. And if two switches are located in same rack or in same logical location, we run iBGP, and the switches which are located in kind of different locations, we run eBGP. So when billing engine, when it is asked billing engine to figure out which switches will be on the way between these two endpoints, so billing engine just checks BGP routing table, and looking into AS path, it is clear which switches are on the path towards the between endpoints of the circuit. Then we need someone who will be using this thing, and Sophia Connect, an innovative carrier, thanks to Sophia Connect, they started using this technology on their production network, which helped us a lot, actually. We did a lot of improvements, but approach proved to be kind of production ready. Up to that point, we understood that we solve automation problem, and we get some freedom of choosing between different hardware vendors, because as I told, those white box switches which work with this approach are available from about 8 vendors on the market. We were inspired and decided to go further to find out new problem and new challenges. So what about data center deployments? During decades, network-to-network relations in data center were evolving. So starting from this old core distribution and access layer, data center networks became kind of advanced fabrics running BGP and overlay technologies with better scalability, but still server-to-network connectivity is still using legacy technologies, like so spanning tree broadcast, multi-chassis lag, and some other problems are still in the data centers. So we decided, let's try to remove shared segment between server and top of the rack switches and see what will be. So we will remove broadcast, we will remove lag, and there will be no wasting of IP addresses on subnetting, no VLAN borders, and also we decided that stacking top of the rack switches is not very good idea. So we decided that servers should become part of the switching fabric. And we came to this network, so we built a fabric of switches running BGP on every switch. And as I said, thanks to Cumulus networks, it is today easy to run BGP unnumbered, not only on switch side, but also on server side. So we decided to run BGP between server and switch. It is not actually hard. It's very simple, because with BGP unnumbered, we don't need link IP address. So we just say, I want BGP on this port. We set up just one loopback IP address on the loopback. We connect all the server link to all possible switches, and we run BGP over all those physical links. So in this case, top of the rack switches don't need to be staked. So one switch doesn't know anything about other switch, and that's great. So failure on one switch can't bring to failure on another switch. We have BGP attributes for traffic engineering, which is very flexible. And to even simplify the configuration on server side, we came to kind of standard configuration, and we put this configuration into QAGA package. So when network engineer doesn't need to deeply learn BGP, but just to install the QAGA package, which comes with the standard configuration already inside. With this network, we decided that because switching silicon has ability to filter traffic, so we decided to move access list on the level of switch silicon. But switch silicon has comparatively smaller TCAM size comparing with big firewalls. So if we apply access list on the switch globally, then we will end up with wasting the TCAM. So BGP is our friend. Again, we decided to use BGP here. Because we run BGP between servers and switches, we precisely know which IP addresses is located behind which physical port. So when web server engineer wants to get an access to the database, they go to intuitive web portal. They use their mouse and some keys on the keyboard. It's very simple, just 5 seconds. They type this IP, and this port. Then the software which is running on every switch pulls this information from the centralized database, then compares with the BGP table to figure out that this particular rule is relevant for this particular port, and sends this rule to the ASIC for the proper port. So with this approach, we found a way to use switch silicon resources efficiently. So considering this, Broadcom Trident 2 allows 4,000 of ingress ACLs. And server mobility became easier, because when you move, currently when you move server from one rack to another rack, first you don't need to tell network engineer to configure the VLAN on another rack. You just go to the interface and say, I am moving my server there. And when BGP comes up in new location, the access lists are following the server. So in new place, the server is up and running with the access list in place. So Anycast for load balancing has been used in the internet for decades for load balancing for redundancy of DNS servers or some CDN platforms. So since we have BGP here, we decided why not to use Anycast for load balancing here. Switch silicon has ability of ECMP hashing. So it works following way. So, oops. We configure unicast IP addresses on every server, and another Anycast IP address, which is the same for every server. So servers are advertising their anycast IP addresses with the same metric to all the switches, and there is ECM standard equal cost multipath routing. So traffic is balanced between servers, considering hashing based on source, destination, IP, protocol, and port. So when server goes down, BGP is down and traffic is rerouted. And what to do if Apache is down, for example, but the server is operational and BGP is up? So piece of software which is running on every switch is contacting with the unicast IP addresses, checking if service is alive. And in case service is not alive, but server is running, again, traffic is routed using BGP attributes. We decided that we should make the same with the virtual machines. Will be great if physical and virtual machines will have the same treatment, same approach. We currently tried this with OpenStack and Proxmox virtualization platforms. So what we did, this is the classic hypervisor where virtual servers have some virtual interfaces. The traffic is passing through IP tables into the bridge, which connects to physical interfaces. Because idea was to run BGP between server and the network, we did following. So we run QAGA, we run BGP inside the hypervisor. So there is a BGP session between hypervisor and switches in the fabric, and we pull out every virtual interface from the bridge and terminate it locally, enabling IPv6, because BGP unnumbered is using IPv6 for establishing BGP session, IPv6 link local, I mean. So we pull out the virtual interface, we enable IPv6 on those interfaces, they get IPv6 link locals, and they establish BGP between virtual machine and hypervisor. So everything advertised from virtual machine goes to hypervisor, which advertises to the rest of the network. So what about Microsoft operating system? Microsoft running BGP on the host. So it sounds at least strange. But actually, Microsoft server, starting from 2012 R2, it supports BGP natively without installing anything. It really supports. Of course, not without problems. So, of course, BGP unnumbered was not supported. It refuses to work when advertising IPv4 over IPv6 adjacency, though according to documentation, they claim that it should work, but it doesn't. I don't know why. But we found kind of a trick. We configure IPv4 link local addresses and start advertising the real IP address from the loopback. And thanks Microsoft, it works. So Microsoft Windows understands that the loopback, that link local IP address is not good for originating traffic, and that helps. So they understand to put the loopback IP into the origin, into the source of the packet, which is very crucial for this approach. A lot of people told us that, okay, that's interesting, but it's not production ready. So thanks to another creative company called Innova, they actually run this routing on the host approach on their live infrastructure, and they don't waste IP addresses anymore on subnetting. So one server consumes just one IP address, I mean IPv4 address. So they don't need to lose another 20 IP address on subnetting. And because of that, Innova was able to remove all the net used. Today, their network are running purely on public IP addresses, and they are kind of bringing back original concept of the internet, which says that internet is a network between where every IP address should have reachability to every other IP address. And finally, they decided to fully swap their existing Cisco Juniper F5 built infrastructure to our solution, currently serving 24 million of user base using approach which I have described. So routing on the host is something real, and it is already used on live production network. Summarizing what we got, the automation, access list collected in the centralized place but deployed on the network level, load balancing in many cases without using separate load balancers, hardware disaggregation from giant vendors. I respect everyone in Cisco and Juniper, but let's try to disaggregate, maybe it's time. And better agility with the operations. So I want to say special thanks to Attila de Groot, he's sitting there, Sean Cavanaugh, Pete Lumbis, Stefan Enns, and the rest of the Cumulus Networks team, which they were helping us a lot. So thank you, guys. Thank you.
Any questions? And I'd also like to encourage people who aren't necessarily the usual suspects to also step up. So, yeah.
Hi, my name is Osama. I'm not representing anybody. Osama Dasari. So I wanted to ask a question with regards to the BGP routing. Are you doing in the virtual environment scenario? Are you doing the BGP routing between every VM and
hypervisor?
And hypervisor.
So every VM has a BGP adjacency with the hypervisor, and hypervisor has the BGP adjacency with the top of the rack switches.
Have you considered relying on the hypervisor itself to get the status of the VMs without the need to run BGP with all the VMs? So the hypervisor itself, given that it knows all the IP addresses of all the VMs, simply in the status of all the VMs?
Yeah, got your point. But yes, because we're doing this anycast load balancing, so it was actually important that the virtual machine advertises its anycast IP address locally.
Yeah, so if the hypervisor itself, it knows the status of every VM, so it can say if it's up or down, and it can basically remove or add a route. Yes,
but also there's actually also a case of moving virtual machine live migration. So during live migration, sometimes there is a situation when the instance has been moved, but the older hypervisor still thinks that VM is running. So that causes problems.
Thank you.
Thank you.
Jelenkova, 2 questions. Could you please elaborate a bit on scalability of this? Because it looks like you are running a lot of BGP sessions. Do you use kind of route reflectors and so on?
Yes, sure. Of course, we run route reflectors. The spine between leaf and spines. So spines are route reflectors, and the spine layer and hypervisor layer are different AS numbers, so there is eBGP.
Okay, and the second question, with all this multipath, especially using link local, what do you experience with troubleshooting this when you need to make sure you send packets to a particular path during troubleshooting?
So Paris trace route. And sometimes we apply some access lists on the physical switches to check counters to figure out if particular traffic is here or not. Yeah, and most of that.
Just, it's my voice maybe. Emil Aben from the RIPE NCC with a question from a remote participant. This is Sasha Luk from SIX. Question is, what is the Quagga Cumulus package you are using on the hosts?
What is what?
The Quagga Cumulus package you are
Yeah.
using on the hosts.
It's Cumulus Networks are running an open source project, which is actually a fork of Quagga, which is today actually renamed to free range routing, but it is partially based on Quagga source. And Cumulus Networks developed the part of the BGP unnumbered, which was very important for doing all this stuff. But it is still open source project, so anyone can contribute to this project, can use the code freely and like normal open source project.
Benedict Stockebrand, Stepladder IT. I see one huge problem here, but maybe that's because I've spent too much time in enterprise environments rather than, ISP or whatever contexts. It's bad enough to have the VMware people trying to run these things come to grips with basic network concepts like VLANs and, I'm not going to talk about dynamic routing even, but actually running BGP on a Windows box sounds scary to me. Not because of BGP or Windows, but because of the combination and the layer of 8 problem in front of it. And I'm not even going to comment on having database people get control over firewall configurations, because that's inevitably ending allow everything from everywhere to everybody else. So this is as interesting as it is from a technological point of view. In a lot of environments I've seen, this approach is infeasible at best and absolutely scary if you just really think about it.
It is actually, and as I told, not without problems, and we experience a lot of problems with the Windows, but right now at this very moment, as I told, the company called Innova, they are in gaming business, and most of the game servers are requiring Windows, and it actually works. Finally it works.
Okay, in that case, if we talk about gaming servers, yes, this is a very difficult business, but if something goes down, yes, it can be scary for commercial operators of these servers, but it's not like in a lot of enterprises where you don't have the luxury, as Brian mentioned before, of having the occasional unscheduled downtime and no repercussions.
Okay.
Well, first off, as someone who's also run some databases, let us remember that there are many database people who have a very wide range of knowledge. And also, let's cut off the lines after everyone in line. Randy? Okay, sorry.
Christian Petros, Danik. I have one question about the security. If you have a web portal where every customer can do the stuff he needs, how do you prevent that you open up a hole you don't want to open up?
Yeah, thanks for the question. We actually, what we do, we create different tenants. We assign users to tenants. So tenant represent a customer or project. Then we assign different resources. It can be physical ports or IP address or physical server, whatsoever. So we assign resources to the tenants, and every tenant can freely do with the resources within its tenant. And at the moment when tenant wants to do something between its and other tenant, for example, to create a circuit or to request access to the neighbor's database server, the system, we check whose resources are engaged in this request, and we send this request for the approval procedure for another tenant. Another tenant should make sure that, should say, okay, I agree that that's gonna be happen, and only after that we apply. So it doesn't avoid security procedures, kind of, but it improves. So kind of life cycle is easier.
And do you have a standard access list or something else where some stuff is blocked?
Yes.
First, yes. Okay.
Yes. White list, black list.
Oh, okay.
Yeah.
Interesting stuff. Thank you.
Thank you.
All right, let's keep these next two questions very brief, if you can, Randy.
About 15 years ago, I moved from a highly automated network to one of the larger telcos in the world, and I started to talk about automation, and the first thing I heard was the network is the database of record. That's a form of suicide. I strongly suggest that Bernard's advice be taken by all my competitors and do not use a database to manage your network. Do it with monkeys at keyboards. It's great.
Okay, thanks. Thanks for the comment. We actually work a lot to make database network be more safe. And maybe next time I will propose a presentation how we do database, what precautions we consider to make database-driven network safer.
And our last question.
Friso Veenstra, Rabobank. We do have a network which you would call a legacy. We've still got VLANs, we've still got switches, we've still got Cisco, we still get F5s. And I want to talk about the F5 thing. One of the things about load balancing, you were talking about saying, well, we use BGP multipath, and that way the traffic is separated over all the various servers. One of the things our F5s do is have something called session states. A lot of multipath and multicast or any cast over service over internet works, for instance, with DNS, which is not session oriented. We have a lot of sessions which are session oriented, and the session state is very important for the session to actually work and give something back. MQ, Connect Direct, those type of protocols need session states. If in ICMP, in multipath, if you suddenly switch to another server which is not aware of the session state, the session is normally broken, and you don't want that in a normal network. How do you cope with that in your solution?
Yeah, thanks for the question. Actually, we are not trying to replace F5 like firewalls, load balancers for 100%, but in some cases this approach works. And first, ECMP considers hashing. So until switchover, the sessions are going to the same servers. As you told, yes, switchover is a problem, but there is another, with this approach, there is another opportunity for the network. They can use tools like HA proxy or other open source software proxying software, and in combination with the Anycast and such proxies, that the result can be achieved. Of course, not 100% of expensive load balancer, but many companies doesn't need all that features which expensive load balancers introduce.
Thank you very much.
Thank
And
you.
I look forward to your next submission about security.
Thank you. Thank you.
And now we are going to learn about periodic behavior in traceroute sequences for our first of 3 lightning talks.